All right. So what we're doing today, and really what we're gonna do tomorrow also, still involves exponential functions. It's just now instead of like yesterday that had to do with half-lives, mostly were like science and chemistry type problems. Um, these are gonna be more money problems, all money problems. There's the formula for today, just like I gave you yesterday with half-life. But this is going to be about how to calculate interest. What is interest? Kind of like tax. Not necessarily. A tax is a charge that is imposed um, when a transaction occurs, and that money usually goes to the government. But I mean, I'm not an economics teacher either, but um, the only similarity I would say between taxes and interest is that they can both be expressed as a percent. Sales tax, income tax, you can express it as a percent. But the same way you would interest, but they're not the same. Nobody here knows what interest is? Okay, that's pretty good. That's I can I'll clean that up a bit, but yes, that's pretty good. Interest a um, is a fee for borrowing money. Okay. See, like whereas within friends, if I'd be like, hey Nakai, what's up, man? Hey man, look, I need to. Would you mind lending me $20, man? I gotta go get some, but I'll pay you right back. I'll pay you back within a week. And then because me and Nakai go way back, there's a good chance that when I give him back his $20, that he's not gonna ask me for anything else. Just he lent me 20, I gave him 20 back. But that's not the way the real world works. Typically, if there's gonna be money lent to anybody else, who gets involved? Where's all the money? In the banks, right? So, but it works two ways. Okay, you might not realize this, but when you have a bank account and you give money to the bank, it doesn't just sit there in a room waiting for you to come and take it out. Okay, that bank is getting that money and they're spending it and they're investing it and they're trying to make money off of your money. Well, because that money was never originally theirs, it was your money and you are lending it to them. They're holding on to it for you and they're doing what they want with it. Yeah, and later on, if you want to come and get it back, they have to be able to give it back to you. But since they have your money, they pay you for the right to be able to have your money, to hold on to your money, and that's called interest. Okay, same thing works backwards, right? Actually, it's probably even more common. Okay, more common than you giving the bank money is when the bank gives you money, right? When you go and ask for a loan, what are some things that you can get a loan on? A house, a car, yeah. Okay, when you take a loan from a bank and you say, hey, Mr. Bank, you know what? I need $300,000 to buy a house. Okay, please lend me 300,000. The bank goes, yeah, okay, no problemo. As long as you qualify and you have the appropriate income and everything. But guess what? When you pay the bank back, you're gonna pay them back 300,000. You have a lot more. Usually it comes out to about, assuming you get a standard 30-year loan, you end up paying the bank back about three times what they pay you. But that's interest. Interest is a charge that is incurred on just the ability to handle somebody else's money. Yes. Um, um, well, credit is a type of loan. Um, the only real difference with credit is that credit is usually unsecured. So like let's say I go and buy a house, okay? And okay, let's say I go buy a house, right? And I ask for a loan and I qualify for the loan and I get it and I'm able to buy the house. Well, until I pay off that loan, that house is not mine. That house belongs to the bank. But I'm just taking my time paying the bank back for what they lent me little by little, right? Let's say for some reason I stop making payments. What's gonna end up happening? Yeah, the bank's gonna say, okay, well, guess what? House it yours, so it's mine, and they're gonna take it back from you. Same thing with a car. If you buy a car and you don't make payments, it gets repossessed. Those are secured loans. Okay, those are loans that you have collateral. Like if the payments aren't made back with the interest, um, you know, whoever actually owns the loan can retake the possession, right? Well, like credit cards, those are unsecured loans. If I go rack up a $10,000 credit card bill and I don't pay it back, yeah, I mean later on, like assuming that whatever I bought hasn't been consumed, yeah, like if I spent $10,000 to go on a trip around the world, the bank can't come and collect that back. If I bought certain possessions, they can try to repossess it, but for the most part, credit is unsecured. So yes, they're lending you money. If you pay them back within a time frame, there is no interest charged. Usually it's about a month. If you pay back your credit card balance within a month, they don't charge you interest. But then if you don't, they charge you like ridiculous interest. But yeah, interest if it's long answer short, credit like not all types of loans I guess are credit. But yeah, credit is something that interest can be assessed. Anywho, all right. So here's the formula we're gonna use, and this explains kind of what some of those values mean. Um, what's taking the place of the final amount here? Even though they don't have it written, the A is the final amount. What's the initial amount? P. The reason why they use P for financial things is another word you're gonna wanna. Well, you can get away with it, but just if you ever hear it, principal. Okay, and it's actually spelled just like the principal of a school. When you're talking about money, the initial amount that's invested is called the principal. Principal. You're not gonna need to know that for this, but just so that you know that's why they use a P there. It's called the principal. The R means the rate. That's the percentage. Just remember to put it as a decimal, just like you saw on the quiz that we went over. The N, that's what's going to be important here. That's what I want to focus on, is the N. Okay? You see where N says it's the number of times that interest is compounded? Now, there's these adverbs that are used to describe interest. It's like you might see APR. Have you ever seen APR? Like, have you ever seen in like those commercials and stuff? And then at the end, they have the guy talking really fast and, and like to try to squeeze everything in. And then you might hear them like spit out the initials APR, no? Annual percentage rate. Okay, well, the word there being annual. Quarter interest can be compounded quarterly. It can be compounded monthly. So I just want to talk to you what the N would be, what number you would put in for N if you see those words. So like for instance, hear them. If we see another one, like we'll adjust this. But if you see the word annual, where the N goes, like these are all words that are associated with N. The N is one. The N is one. The annual. If you see quarterly, that's another common one. Quarterly. How many quarters are in a dollar? 4. So if you see the word quarterly, put a 4 where the N goes. Semi-annually. No. I don't know. Is there a hyphen in semi-annually? Yeah, there was a hyphen. I wasn't sure if there was a hyphen in it. Semi-annual. No. How many? The prefix sem, or semi. How many semesters are there in a school year? Sem. Yeah, 2. So semi-annual will be 2. And then another one, monthly. Huh? Monthly is 12. So those are all words that you would see that relate directly to N. And then with a T, where you see the T, that's how many years, the number of years. So just like we have in the past few days, let's try to do as many of these as we can. If it gets repetitive, I'll jump around, but I'm not gonna get to all of these in one day. So I'll do as many as I can do. It'd be a good idea to have a calculator out. Here we go. So example one, investment. The Garcias have $12,000 in a savings account. The bank pays 3.5% interest on a savings account compounded monthly. Find the balance in 3 years. So the final amount, we'll just use the capital A like, actually let's do this. Let's do function notation. The amount that's going to be there after some time is equal to, what's the initial amount? It is 12,000. Yeah, but now when I have to come up with the growth factor, the formula gets a little bit tricky. It is a growth. All of the ones today on interest are going to be growth because you're not going to pay somebody to hold on to your money for you. They're going to pay you. So, and none of these problems, as far as I can tell, involve loans where they're loaning you money. So, plus, what's the rate as a decimal? What is the rate as a decimal? Okay, what's the rate? As a percent, huh? No, what is the rate of interest? Well, the rate of interest is 3.5%. That's what it is, but that's what I was asking you originally is, okay, how would that be expressed as a decimal? 0.035 over what keyword that we just discussed is being used here? Monthly. That's where the n goes, so that's going to be a 12 to the power of. That n makes another appearance. Okay, but now instead of division, it's going to be multiplication. 12 times 3, and now let's clean this up. Before we plug anything in, and if you were to be given on the test and you wanted full credit, you would have to simplify where possible. So let's see. 0.035 divided by 12. Give me these decimals. I hate you. Son of a gun. I hate rounding. Oh, what can I tell the children right here? I'm gonna confuse you if I. Do you know how to write 12 as a fraction? Sorry, do you know how to write 1 as a fraction with a 12 on the bottom? So if I wanted to at least combine this to one term, how could I write 1 as a fraction with a 12 on the bottom? Yeah, 12 over 12. Like if I write this as 12.035 over 12, and have I already confused you? Have I lost you already if I do that? This becomes 12 over 12. The denominator is the same. Yeah, I'm gonna, you know what? I'm just gonna run because I can already tell. I'm confused. So I just don't. I'm not a big fan of rounding, but let's round this then to 1.0029. That there's no excuse for you not to know. That's just 0.035 divided by 12 rounded, and then I added 1. I just don't like rounding before I'm done, but it should be close enough. And then what's 12 times 3? 36. So let's put that into the calculator. So the amount that I would have after 3 years is equal to 12,000 times 1.0029 to the power of 36. I'm getting $13,318.52. Obviously, it's money, so if you were to contextualize it, we'll have a dollar sign in front. 13,318.52. Hey, if you got anything different on your calculator, speak now, because if you'd have to have a calculator, but if you got anything different, let me know now so you can figure out what you're keying in incorrectly. Calculator. Nobody? No questions, Shelby? Okay, that was monthly, but this one's monthly. Okay, let's go to number 2 then. I want to try to at least do one of every type. Let's go to number 2. Determine the value of $100,000 investment if it is invested at an interest rate of 5.2%, compounded quarterly for 12 years. Ooh. The amount after some time is equal to, what's the original amount? 100,000 times. Let's come up with a growth rate. It's always going to be a 1 plus because these are growing. What is the interest rate? Okay, good, fine. It's a decimal perfect, 0.052, but it's being compounded quarterly. Quarterly, what number did I wrote it down for you on the board. There's 4 quarters in a dollar. So divided by 4 to the power of. That 4 makes another appearance, but now times how many years? 12 years. Fax machine. I'm just using this formula that I gave you up here. Notice how the n shows up twice. What's another word for the original amount? So you can go home and tell your parents you learned something. What's another word in money for the original amount invested? What's another word for it? Principal. So the amount after some time is equal to, let's clean this up, 100,000, or as opposed to say 100,000, 0.052 divided by 4. Okay, that's a nice one. That's not too bad of a decimal. 1.013 to the power of 48. 4 times 12 is 48. Now just drop it as if it was hot into the calculator. The amount after 12 years is equal to times 1.013 power 8. Not too shabby. I'm getting, with money, where do you round? To the hundreds and, oh yeah, money should be rounded up. So I'm getting 185,888.87. If you got something different, holla. So if they were to rephrase the question, oh, how much money did, they didn't give a name here, but how much money did this person make off of their investment in 12 years? What would you say? What did they profit from the investment? Yeah, $85,888.87. Because originally they gave $100,000, so you can't count that. That was already their money from the beginning. Monthly, yearly. Okay, let's do 3B. Because I'm just trying to do one of every type. And then we can start repeating afterwards. So now it's on Mr. Rivera. The amount after some time. How much did what was Mr. Rivera's principal amount? You have to read in the bold. What was the principal there of the investment? 5,000. And then the growth rate would be 1 plus. What is the interest rate? 0.095, but if you look, it's compounded yearly. What number did I tell you goes with yearly? When what's anything divided by 1? Itself, let's get crazy. What's anything times 1? It's gonna be itself. So here I can just put 0.095, and then up when I do the exponent, I could only put the years. I don't need to put times anything. I still would like to simplify this to make it look pretty. So 5,000, 1.095, power of 10, and then ready, set, calculate. The amount after 10 years is equal to 5,000 times 1.095 power 10. So I'm getting 12,391.14. Sorry, 14 cents. So not a bad R. Do you guys know what ROI stands for?
Rate of interest.
No, not rate of interest, but that's a good guess. Nobody watches Shark Tank. It's called return on investment. How much did this person invest? 5,000. After 10 years, how much did they make back? Well, yeah, they made back the 12, but yeah, if you don't count the original investment, it'd be about $7,391.14. But who's counting? So we did a yearly, we've done a monthly, we've done a quarterly, we haven't done a semi-annual. Let's see if we can find a semi-annual. Quarterly. Oh, here you go. 3. Let's do on the second page, number 3. I just saw that this is a different formula here. So these and I know you like to jump ahead. Compounded continuous interest, I did ask about. You don't have to do continuous compounded interest. You guys don't have to do that. Don't worry about that. For those, it's the growth factor is a number called E. You don't need to know that. So let's do so number 3. Determine the amount of investment. If $300 is invested, so what amount are we going to have after some time? If my initial is $300, add an interest rate of so let's see, 1 plus. The interest rate is 6.75. How would I express that as a decimal? 0.0675 divided by semi-annual to the power of the same 2, but now times the amount of time, which is 20 years. So the amount after some time is equal to, let's see, 0.0675 divided by 2. 300 times 1.03375 power of 40.
Putting the whole.
Am I putting the whole decimal? What do you mean?
Yeah. So like what you gave.
I always like to like the only time I go like if it fills up the entire screen, then you either have to round or figure out another way to put it into the calculator. But you always try to avoid rounding when possible. So the amount after 20 years is going to be equal to let's calculate 300 times 1.03375 power 40. getting $1,131.73. This person made about $831, almost 832. All right, let's do number 4 just for fun, because I actually just found a new one, a new word. I don't think you'll be asked for this. I've never heard of interest compounding weekly, but I guess it could. Hans opened the savings account by depositing $1,200. So the amount after some time is equal to the initial $1,200, and its money's gonna grow. That earns 3% interest compounded weekly. What How do you write 3% as a decimal? 0.03. And if you read on, they end up telling you, but even if they were not to tell you, because it's not exact, but it's pretty close. Whenever somebody asks you how many weeks are there in a year, what is commonly referred to as? How many weeks are there in a year? Yeah, 52. If you keep on reading, it does say assume that they're exact. It isn't exact because how many days are there in a week? That's exact. 7, right? So put 7 times 52 into the calculator. What's 7 times 52? 364. How many days are there in a year? 365. Yeah. So it's off by 1, but commonly when somebody asks you how many weeks there are in a year, typically we say 52. So it does tell you to assume that it's 52, and I would write that down the same place that you wrote down before about what numbers to associate with what words. If you see the word weekly, put 52. I really don't think that it's it, but. And then number 52 is going to make another appearance up here. And then times the 10 years. So we clean this up and say the amount after some time is the $1,200 principal. What is 0.03 divided by 52? See, like this filled up my screen, so now I got to figure out. I hate rounding, but now I got to figure out where to round. Son of a gun. Here, let me just try to do this one differently, and then if you guys pick up on it and you understand how to do it, great. Look, get whatever number's on the bottom and put it next to the 0.03 on the top. You can put 52.03, but then just keep it on the bottom like that. Same thing. If you don't understand how I got it, it's fine. It's just this decimal is really not, and there's a bunch of zeros. Like the rounding would get really ugly with that. With that 0.03 divided by 2, so I wrote it that way. If you don't understand how I got it, then round. But you're going to be rounding to like 7 decimal places. To the power of 520. So what I would do on most calculators here, I would do that 52.03 divided by 50 first, hit equals. Then take that. Why did I get it? Wait, hold on. Why did I get a different? Oh, because I put by 50. Sorry. 52.03 divided by 52. Okay, then I get that nasty decimal again. To the power of 520. And then at the end, so I'm basically teaching my calculator order of operations. And I get that the amount after those 10 years, and they wanted it to the nearest cent, would be $1,619.69. Anybody get anything different? Um, okay, here. Go to the next page. Just come to number 10. Let's do all of these quickly. So, remember annual? What number am I going to put for n on annual? What number am I going to put for semi-annual? What number am I going to put for n on quarterly? What number am I going to put for monthly? What number am I going to put for daily? That's another new word. 365. Yeah, 365 would be daily. So you might want to add that to your list of words. Now, what all of these would have in common is that the amount after some time would equal 10,000 times 1 plus 6%. I don't know why they put PA. They say rate. So, like, I don't even know what PA stands for. But the rate, the interest rate is 6%. So 0.06. Now the thing is, though, on all of these, you're gonna have to take turns dividing by a different number. So like whatever each of those n's are, you would put that there, and then up here you would put the n times the amount of time is 3. So let me actually just do that just to see. But already I'm going to be plugging in 3 because it's 3 years. So you can put the power of. So if you're good with the calculator, I'm just going to give you the answers, and then you can go try to do these on your own, because I can do these pretty fast. 10,000 times 1.06 to the power of 3. So if we compound annually, that 10,000 is turning into 11, 9, 10.16. If you compound semi-annually, I'm getting 11, 9, 40.52. Compound quarterly, I'm getting 11. I would do these for you step by step, and the bell wasn't going to ring yet, but I just wanted you to see the answer so that if you do them later, you can check if you got the same thing. For monthly, yeah. Yeah, I'm doing that. I'm dividing by each different number. I'm doing that. I'm doing it fast. 11,966.81, and then the last one daily. 5 plus 1 power 3. Getting 11. So, like, the purpose of a problem like this, where they ask you to compound it all these different ways, is then since we kept everything else constant, it was the same initial investment, the same interest rate, or the same amount of time. The only thing that we changed are the years. Then you ask the students, well, geez, if I'm the one lending the money out, is it better for me to be receiving interest annually, semi-annually, quarterly, monthly, or daily? What would be the best type of interest to receive? Yeah, daily, because if the money's compounding more, you can tell that you get more money there. Well, but it also wasn't a lot of time. If you do that over 30 years, you would, the more time that passes, you would see It would separate. They would separate the amount of the difference would be bigger. The biggest one is a formula that we don't cover, which is continuous. Continuous compounded interest is like what the credit cards use and stuff. That's where it really starts adding up.